parallelograms. We'll look at this special type of quadrilateral, which by definition is a four-sided polygon where the opposite sides are parallel. Now with this definition, so we'll say four-sided polygon where opposite sides are parallel. Now, what other properties can we derive from just knowing this one fact? Well, we are going to use our knowledge of triangles in parallel lines to derive some additional information. The first of which, if we have parallel lines, then we know that consecutive angles, so actually I'll label numerically, are supplementary because they are same side interior angles. So that's the first property we'll bring up. So same side interior. You have your parallel lines. The other line acts as the transversal. So 1 and 2 equals 180. 1 plus 3 equals 180. So there's your first property. Other properties are going to be found by dividing this quadrilateral into triangles. So if I draw a diagonal, then we can figure out some other properties. For instance, this angle here is congruent to that angle there because there are alternate interior angles. And if I know also that this angle is congruent to that angle by the same reason, and the fact that these two triangles share that diagonal, we have just identified that these two triangles, I'll label the sides, or sorry, the angles, so we can give these a name. We can say triangle ABC is congruent to triangle CDA by angle side angle. So we incorporate a diagonal shared amongst the two triangles by reflexive property, and then identifying angle congruency because of our definition of the parallelogram having opposite sides parallel, we can identify alternate interior angle congruency there. So if we know the triangles are congruent, then we can make the conclusion that AB is congruent to CD and BC is congruent to AD because of CPCTC, because we know corresponding parts of congruent triangles are congruent. So from that, we have come up with our second property, and that opposite sides are congruent. And that is from, so we're going to say because triangle congruency and CPCTC. Next, what else can we discover? Well, we can also add in that by the third angles theorem, angle B should be congruent to angle D. And if this is angle 1, say that angle 1, this would be 2, and that would also be 2. Well, both those angles A and C are a composition of 1 and 2. Therefore, they should be congruent to each other. So we also now know that opposite angles are congruent. Part of that reason is the third angles theorem, which says if two of the three angles in two triangles are already congruent, the third pair must be congruent due to the fact we know they always sum to 180 degrees on the two-dimensional flat surface. So third angles theorem, and we'll say angle addition postulate, right? So the sum of the whole, or sum of the parts equals the whole, and because the parts are the same for A and C, we know that A must be congruent to C. Now the last thing, we'll start over, What if we draw two diagonals in there? So if we have two diagonals and we already know that these properties hold, we can say this side is congruent to this side. Okay, by alternate interior angles. This angle is congruent to that angle. And this angle is congruent to this angle. Therefore, these two triangles that intersect at E, so ABE, is congruent to CDE by angle side angle. And if that is true, then by CPCTC, the corresponding sides, so this side and this side, BE and DE are congruent, as well as AE and CE by CPCTC. Now what we just identified there is the diagonals get bisected. And that's our fourth property. I say they bisect each other. And we came to that conclusion by identifying triangle congruency and CPCTC. So there are your four properties of the parallelogram. So if we know we are dealing with a parallelogram, then we know by definition that the opposite sides are parallel. And it's also true that these four properties hold. Now, let's say that we aren't sure if we do have a parallelogram, but we want to identify if, in fact, the quadrilateral we are looking at is a parallelogram. We want to check out for certain conditions. So again, these are properties. We know we're dealing with a parallelogram. So parallelogram is known. Okay, these are true. Now, what must be the case if we're trying to identify one? That's where the conditions come into play. So now let's look at conditions for parallelograms. The first of which is if you identify opposite sides are parallel. If that's the case, then you have a parallelogram by definition. Now, what can you use to identify opposite sides are parallel? We might use converse theorems that relate to angles that are formed with lines and transversals. So that's what we're going to be on the lookout for, because this is ultimately what we want to show, because the definition of a parallelogram is that opposite sides are parallel. So if we can identify that right away, we know we're dealing with one. But let's look at some other properties that must be true. One pair of opposite sides are parallel and congruent. So imagine if we have some quadrilateral and we see that opposite sides are parallel and congruent. So why is it true that this is definitely a parallelogram? Well, let's go back to incorporating our diagonal and therefore these two triangles and see if we can get some information out of that. Well, if these lines are parallel, then this angle is congruent to this angle, okay, by alternate interior. And these two triangles share this side. So now what we just showed was that those two triangles that form that quadrilateral are congruent by side angle side. And if they're congruent by side angle side, then we can get the information that this angle in here must be congruent to that angle in there by CPCTC. And if those two angles are congruent, then we know this side is parallel to this side because of the converse of alternate interior angles. So all we need to identify is we have a pair of parallel sides that is both, one pair of parallel sides that is also congruent. If it's also congruent, we can derive the fact that the other pair of sides are parallel through this triangle congruency and converse theorems related to angles. How do we get those angles congruent? The CPCTC. So that's why that is true. So if we identify that, we know we have a parallelogram, and the reason was just shown. For 3, what's our third condition? Third condition, both pairs of opposite sides are congruent. Now this should make sense because that was one of the properties of the parallelogram, so working in reverse, that should be true. But to show why it's true, again, we want to be able to show that the opposite sides are parallel because that's what gives you the parallelogram by definition. So if we know the opposite sides are congruent, as you can probably guess, it's divided into triangles. They share this side. So by side, 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 these triangles are in fact congruent. And if they're congruent, then by CPCTC, we can identify corresponding angles are congruent. And if these are the angles that are congruent, then by converse of alternate interior angles, we can say this side's parallel to this side's parallel to this side, and therefore we, by definition, know we have a parallelogram if both pairs of opposite sides are congruent. So let's look at the next one. We're looking at angles. If that is true, well, let's assign some letters to this. We'll say A, B, C, D. So maybe a different approach from the triangles. Let's say that we know if we have a quadrilateral, the sum of the interior angles should equal number of sides minus 2 times 180. So there's 2 triangles that can be formed. We've seen it again and again. Each one's 180, so a total of 360. So if we add together angles A, B, C, and D, we know that should total 360. But we know A and C are the same, so we could say instead of C, let's replace with A, and B and D are the same, so let's replace that with B. So then we have 2A plus 2B is equal to 360. Now, if that's the case, if we factor out a 2, we've just identified that A plus B is equal to 360. Now, if A plus B is equal, 180 by dividing by 2. Now, if A and B are 180, then those two things are supplementary. And if we have consecutive angles that are supplementary, then we know that these sides are parallel by the converse of same side interior angles theorem. And using that same idea, if B is the same as D, well then A and D are also supplementary. So that means these two sides are parallel because if these two angles add up to 180, then by the converse of same side interior, they are also parallel. And by definition, if we have opposite sides parallel, we have a parallelogram. So knowing that opposite angles are congruent verifies that we do have a parallelogram, as shown through angle relationships. Number 5, one angle is supplementary to both its consecutive angles. So that kind of relates to what we just showed. So if we know 1 plus 2 equals 180, and we know 1 plus 3 equals 180, and again, by the converse of same side interior, we know that this is parallel to this, and this is parallel to this. Okay, and opposite sides being parallel reveals that you do in fact have a parallelogram. What's important to note, it has to be both its consecutive angles. So if 1 plus 3 did not equal 180, there's no guarantee that we have a parallelogram. So it's not enough to just see that one angle is supplementary with the original angle. So here's an example where 1 plus 3 would not equal 180, and you can clearly see that we have a trapezoid instead of the parallelogram. By the way, the definition of a trapezoid is that one pair of sides is parallel for the quadrilateral. If we have both pairs parallel, then the parallelogram. If only one, we have the trapezoid. So make sure it's both. Pay attention to that condition. And then the last condition is the diagonals bisect each other. So if we can identify this, then we know we have a parallelogram. So if we have the diagonals and we know they get bisected, then we can see that there's vertical angles here. So those two triangles are congruent by side angle side. And if those two triangles are congruent, then we're going to have corresponding angles being congruent, which means that this is parallel to this. And we could also say that the triangles that line up vertically, we know this angle is congruent to that angle by vertical angles as well. So we could also say that this angle, that angle is congruent to that angle down there. So these are parallel as by converse of alternate interior as well. So again, we were able to determine that opposite sides are parallel, and therefore by definition, we have a parallelogram. So that's why those conditions hold true and why that is all you need to identify a parallelogram for each one. So you don't have to go through that process, but understanding why those are the only things that are necessary to identify a parallelogram is explained there. So that's what parallelograms are all about, and that is the conclusion of this video.